Ever feel like, life is just one big word problem?
Well, get ready to, embrace your inner math whiz.
Yeah.
Because today, we're diving deep into the fascinating world of mathematical modeling.
Ooh, exciting.
We're going to uncover how math helps us make sense of everything from, fuel efficiency
Right.
to financial goals.
Yeah.
And even predict things like, enrollment rates.
I never thought of it like that. That's really interesting.
What's really cool is we're often using these models without even realizing it.
Really?
They're like those behind-the-scenes heroes in movies, quietly making things make sense.
Yeah, that's true. It's like they're working behind the scenes to make everything add up.
Exactly.
And like any good hero story, we're going to break down the steps to building these models, making it clear and fun along the way.
Absolutely.
Which I think is really important because I think sometimes people shy away from math.
Right. I think what often trips people up is they hear mathematical modeling.
Yeah.
And think it's all super complicated equations and stuff.
Right, exactly.
But the truth is, it all starts with something most of us are pretty familiar with. Word problems.
Okay, let's unpack that a bit.
Okay.
I'll admit, word problems weren't exactly my favorite thing back in school.
Right.
How about you?
But they really lay the groundwork for understanding how this whole modeling thing works. Think back to those classic road trip scenarios, for example.
Okay.
You're driving across the country.
Mm-hmm.
How do you figure out how much petrol you'll need?
Well, I'd probably start with how far I'm driving, right?
Right.
And how fuel efficient my car is.
Exactly. You're instinctively identifying the key variables.
Okay.
Distance and fuel consumption rate.
Right.
And you're right to ignore things like, the color of your car or how many snacks you've packed.
Right.
Because those factors don't directly impact your petrol needs.
No, they don't. That's true. So in a way, I'm already doing a simplified version of mathematical modeling in my head.
Yeah.
That's kind of cool. I like that.
You got it. And to take it a step further, we can actually represent that relationship between distance, fuel efficiency, and petrol needed with a formula.
Okay, so let's say my car gets about 12 kilometers per liter.
Okay.
And I'm driving 432 kilometers.
Okay.
A little number crunching tells me I'd need 36 liters of petrol.
And there you have it, a simple mathematical model.
Wow.
It takes a real-world situation and translates it into a format where we can make calculations and predictions.
It's like turning a real-life situation into a solvable equation. I like it.
Exactly.
Okay, but what about something a little more financial?
Okay.
Yeah. Let's say I'm saving up for a new washing machine, like many of us do from time to time.
Sure.
How can math help me figure out how long it'll take to reach my savings goal?
This is where things get interesting because we start to see the role of assumptions in mathematical modeling.
Ooh, assumptions. Okay.
Let's say the washing machine costs $500.
Okay.
And you can save $50 a month.
Right.
A simple calculation might tell you it'll take 10 months.
Right.
But what about interest earned on your savings?
Right. See, I wouldn't even have thought to factor that in. So assuming a constant interest rate, even though it might fluctuate in reality,
Right.
can give me a more realistic estimate.
Precisely. It might seem like a small detail,
Okay.
but even a small interest rate can make a difference in the long run.
That's true. Yeah.
For example, a 2% annual interest rate could shave a month off your savings time,
Oh.
while a 0.5% rate might only make a difference of a few weeks.
Wow. Those seemingly small differences can really add up.
Exactly.
So even with something as straightforward as saving, a model can help me understand different scenarios and make more informed decisions.
Exactly. And sometimes we need to juggle multiple factors at once.
Right.
Which is where things can get a bit more complex. Imagine trying to figure out the speed of a motorboat traveling upstream against a current, and then downstream with the current.
Now, that sounds like it requires some serious math. How would we even begin to model something like that?
It's actually not as daunting as it might seem.
Okay.
In a situation like that, we can use multiple equations to represent the different aspects of the problem.
Okay, so you'd have
So one equation would capture the boat's speed relative to the water,
okay.
while another would account for the speed of the current.
So it's like solving two pieces of a puzzle that kind of fit together to give you the complete picture, right?
Exactly.
Okay.
And by combining those equations, we can isolate the boat's actual speed, both upstream and downstream.
Okay, that makes sense.
But this actually brings up a crucial point about mathematical modeling.
Okay.
It's not just about plugging numbers into equations and getting an answer.
Right.
It goes a step further.
Okay.
And this is where the idea of validation comes in.
Validation. Tell me more. It sounds kind of official.
Think of it like a reality check for our mathematical ideas.
Okay.
We've built a model, we've gotten our results,
Right.
but now we need to see if those results actually, hold up in the real world.
Right. They could just be nice in theory.
Right.
You need to actually test them out.
Exactly. We need to compare them to actual data and observation.
So it's like comparing your answer key to the test results.
Right.
Did you actually get the right answers?
Precisely.
Okay.
And if our model's predictions don't match up with reality, it's a sign that we need to go back and refine our model, maybe adjust some assumptions or consider other factors we might have overlooked.
Right, because maybe the model itself needs some tweaking.
Exactly.
Okay, I'm starting to see how this all comes together.
Yeah.
But I'm curious, can we take a look at a more complex real-world example?
How about
Something that goes beyond these, more straightforward scenarios.
Let's dive into a case study that explores a critical Millennium Development Goal.
Okay.
Increasing girls' enrollment in primary schools in India.
Okay.
We have a table of data that shows enrollment percentages over several years.
Okay, so where do we even begin with something like that? It seems like a lot of data to unpack.
You're right. It's important to have a systematic approach. First, we need to choose how we'll track time.
Okay.
And in this case, counting years since 1991 makes sense.
Okay.
Then we look for trends in the data.
I see. And looking at the numbers, it appears that enrollment has been generally increasing over time, which is encouraging.
It is. And to build our model,
Okay.
we might start by assuming a steady increase
Okay.
to keep our initial model simple.
Okay, got it.
Don't worry, we can always, refine it later.
Of course, yeah.
This lets us create an equation
Okay.
to represent this relationship between years since 1991
Right.
and enrollment percentage.
So we're basically looking for a formula that could help us predict, say, what the enrollment percentage might be 5 years down the line.
You got it.
Okay.
Once we have that formula, we can plug in the values
Right.
and get a solution, our predicted enrollment percentage.
Okay.
But remember the crucial validation step.
Right. We can't just trust the numbers blindly.
Right.
We need to compare our prediction to the actual data from 5 years down the line.
Exactly.
If they're way off, we know our model needs some tweaking.
Exactly. And that's where things get really interesting.
Okay.
Let's say our initial model, assuming a steady increase, isn't quite accurate enough.
Okay. It's not quite there.
Yeah.
What could we do to make it a more realistic reflection of the situation?
Right.
Well, maybe the rate of increase isn't perfectly steady.
Right.
Could we factor that in somehow?
You're on the right track.
Okay.
We might introduce something called a correction factor
Okay.
to account for any consistent discrepancies. We notice between our model's predictions and the real data.
So let's say our initial model consistently underestimates the enrollment rate by, a small percentage.
Right.
We could add that percentage as a correction to our original equation.
Precisely.
Okay.
And here's where a little bit of math magic comes in.
Ooh, math magic.
We can actually use a simple method to calculate this correction factor.
Okay.
We won't bore you with all the details.
Right.
But essentially, we look at the average difference between our predictions and the actual data.
Okay.
And that gives us our correction factor.
Okay. So no need to become calculus experts overnight. No.
Oh, no.
But I see the point. We're fine-tuning our model to get a
so.
more accurate picture of what's happening.
Exactly. And when we apply this revised model, we find that its predictions are much closer
Okay.
to the actual enrollment figures.
So it's more accurate.
Yeah, we're getting a much more realistic
Okay.
and reliable representation of the situation.
It's like fine-tuning an instrument to make sure it plays the right notes.
Exactly.
This case study really shows how we can start with a simple model and then keep refining it until it paints a more accurate picture of the real world.
Exactly.
Which I think that's cool because
Right.
it's a process, right?
Yeah.
You don't have to get it right the first time.
And that's how a lot of things work in life, right?
Quickly.
It's all about kind of trial and error and
refining, yeah.
refining, exactly.
Right, exactly, yeah.
Yeah.
This whole process really highlights how mathematical modeling isn't about achieving perfect accuracy. It's about creating a framework for understanding, making better predictions
Right.
and ultimately making more informed decisions.
Absolutely.
Yeah.
This case study with all its, real-world implications perfectly illustrates the core cycle of mathematical modeling.
Okay.
Formulate, solve, interpret, and validate.
Got it.
You formulate a model based on, identified variables and relationships, find a mathematical solution, interpret what that solution means in the context of the real world,
Okay.
and then validate it against real-world data.
And if the validation reveals our model isn't quite hitting the mark?
Then it's back to the drawing board.
We're back to the drawing board, okay?
We refine the model,
Yeah.
adjusting assumptions, considering additional factors,
Right.
and fine-tuning until it aligns more closely with what we're observing in reality. And, this iterative process, this constant back and forth between the mathematical and the real is where the true power of modeling lies.
It reminds me of that saying, all models are wrong,
Right.
but some are useful. We're not aiming for a perfect representation of reality. That would be impossible.
Right.
But we are striving for models that give us valuable insights and help us navigate the complexities of the world around us.
Precisely. And speaking of navigating complexity,
Yeah.
think about the sheer volume of situations where this kind of thinking can be applied.
Right.
We've talked about fuel efficiency, savings goals, even predicting, social trends. But the potential applications are practically limitless.
Yeah, it's like having a new lens to view the world through, right?
Exactly.
I'm thinking about how often we make assumptions or predictions in our daily lives.
Right.
From, planning a commute to estimating grocery costs.
Right.
Even without realizing it, we're often engaging in a simplified form of modeling.
You're exactly right.
Yeah.
And just imagine the possibilities if we bring a bit more of this formal modeling approach into our thinking.
Right, okay.
Maybe you want to optimize your running route.
Okay.
Figure out the most efficient way to pack your suitcase, or even predict the success of your favorite sports team.
Okay, that last one might be pushing it.
Okay.
Some things are best left to chance, right?
Right.
But I see your point. It's exciting to think about how we can use these tools to better understand the patterns and relationships all around us.
And that's a key takeaway here.
Yeah.
Mathematical modeling isn't some, exclusive club reserved for mathematicians and scientists.
Right.
It's a powerful tool for thinking that's accessible to everyone.
So to wrap things up, we've journeyed from those dreaded word problems to predicting real-world trends.
Yeah.
We've seen how math, far from being confined to textbooks, can actually help us make sense of the world around us.
It's about embracing that inherent curiosity, asking questions, looking for patterns, and not being afraid to dive into a little math to uncover the answers.
I like it.
Who knows what you might discover?
That's a great point to end on. Thank you so much for joining me on this deep dive into the fascinating world of mathematical modeling.
It was my pleasure. Thanks for having me.